Hello and welcome everyone to another session in the Data Hour series. We are thrilled to be here with you this evening for a session full of action-packed learning. I am Neelam Thapa, part of the data science team at Analytics Vidya. For those who have joined us for the first time, a brief introduction to the Data Hour session. The Data Hour is a series of webinars conducted by Analytics Vidya and led by top industry experts. It is a fun way to understand the concepts of data science from the leading players in the data tech domain. And as the name suggests, it's just 1 hour dedicated to data. We are hopeful that this session are going to be great source of enrichment and value adding for our community members. Now, on to our session today, which is model parameters versus hyperparameters, techniques in ML engineering. In this data hour, our speaker uh, will demonstrate the significance of parameter tuning and performance of the machine learning model, which improves with a more acceptable choice of hyperparameter tuning and selection techniques in detail. He will also be showing simple use cases for your better understanding. I hope you are excited to attend this data hour with us. So before we kick things off and I hand it to our speaker, a quick recap of the housekeeping items. We are recording the session and the recording will be available on your YouTube channel. The link, you can find it in the chat section. Please use the Q&A section for asking any questions you might have during the session, and we will do our best to answer them as the data hour progresses or towards the end. We will be sharing a feedback poll towards the end. You are requested to kindly fill that up before leaving the session. Now on to our speaker. In this session of Data Hour, we have Shanta Babu Pandyan with us. Shanta Babu is currently working as AIA architect and delivery with Cognizant. He has a good experience of 20 plus years in information technology, IT. He has done his PG program in artificial intelligence and machine learning from Great Learning and University of Texas. Over to you, Shantababu. The virtual stage is all yours.
Yeah, thank you. Thanks everyone. So special thanks to Analytics Vidya and Thapa for this wonderful evening. So let me share my screen and please confirm like we're able to see the content. Okay. Right.
Yes, it's visible.
Excellent, excellent. Okay, guys. So I could see around 60 plus the folks actually joined. So thanks everyone. So I'm not sure like where you guys are belongs to. So it could be a morning, afternoon, or evening. So it's a great opportunity for me to just spare my time with you guys. So today's topic, it's like it's model parameters and hyperparameters. So try to understanding that what it's going to be and how we are going to use this specific thing when we're building the model. Okay. So and the major techniques which involved in when we doing like a model machine learning building the model aspects. So I'll try to cover as much as possible because the area is really bit vast area. I mean, like, so the parameter is just a simple term, but so believe me in that it's like a very huge impact when we are building the model. So that's the reason actually I picked up this specific the topic today. So without further delay, so let's jump into the content. So right. So guys, so let's try to understand what is tuning basically. So basically the tuning, so hope you guys like, this is an analog radio. So I think I'm not sure like how many of you are familiar with this, or else like probably you can see this one. Nowadays we have some digital FM radios and all, right, in our house. So probably there can be like the packet radio we used to say. So when we want to select a specific the channels, so what we used to do, so we used to tune that the provider over here, lighter, yeah. So this is a provider actually we used to tune and we get the exact what we're looking for. So we're not sure about like which FM we want, right? So 98.5, 99.5, 100, 107.5, something like that. So there are multiple things in our in general way. So we used to tune that and we get the exact the channel what we are looking, right? So keep this specific item in your mind, and then let's we focus on the rest of the item in our session so that you can understand better. So here I'm giving the two big circle, that is nothing but model parameter as well as the hyperparameter. It's like looks like a something like a Greek and Latin. It doesn't matter. So because it's already like it's available in our when we're building any model, so it comes along with that. It doesn't matter like need memory on that, right? And the same way for model parameters, also very crispy and very easy to understand, right? And so before this one, I think you guys are agree with me. So you, as I said earlier, so every ML engineers and data scientists work at MA, there is no difference like in the role base. So it's a case by case, like I mean, like industry specific or organization specific, there might be a role may be different. But at the end of the day, both the scientists and ML engineers used to do. But nowadays, they are giving some drastic line between the engineers and data science. But based on my understanding, so both are not much difference. So ML engineers and data scientists must understand the significance of hyperparameter tuning while selecting the right machine learning or deep learning model to improve the performance of the model. So if you ask me like, hey, I don't want to care about like hyperparameter or parameter, whatever it is. Parameters different way. I'll tell you that in the upcoming slides. So hyperparameter is a very important thing. You may say, I can go with whatever the available, what is that, the value, I can go ahead and submit and I can go ahead with this hyperparameter means, yes, very well, you can go ahead. That doesn't matter. But when you are applying into the real-time scenario, your the stakeholders, you have to give the answers to the stakeholders. That is very important. So the ML engineering, ML projects totally differ from your the normal application development and deployment in the production, because the ML is totally different. The way it's handling each and every stage is totally different. So, and each and every stage we have so many nut and bolts on that. So in that, the specific hyperparameter tuning is a very important nut and bolts, I would say. If it is very loose, so let's say, for example, if your bike or your vehicle, the nut and bolts is not in good condition, so you cannot drive the vehicle, right? So the same way, the hyperparameter is performing the very important role. If it is even in this the kind of ocean way of the ML implementation, the hyperparameter is playing a bigger role here. So with this condition and agreement, let's move on to the deep dive. So as I mentioned, it's like it's a model parameter, and the hyperparameter is a big circle, I would say. But when I compare with the model parameter, hyperparameter, it's a very huge thing because there are a lot of things in it, right? And when it's going to be a model parameter, it's a very simple understanding. So easily you can grasp that. And hyperparameter, it's playing the major role. Let's see what is that, right? So when you start with anything, but starts with small steps, baby steps, basically we should say, right? So that aspects y is equal to mx plus c. I hope you guys know what is mx plus c, right? So this is a very basic linear regression, and even is a simple linear regression model. We used to go ahead with like y is equal to mx plus c. And I'm going one step back in your college days. So you guys like get a chance to work out with this kind of like solving that linear regression model. By the time, even when I doing my engineering and all, so I never bother about like giving the data, and I used to do and finding the m and c, and then I'm finding the value of y after finding my slope and coefficients, right? So the same way here. So let's, in a few minutes, we'll check this one. So what it is like, then only we can understand what exactly the parameter and the hyperparameter. Look at guys here, with respect to the machine learning language, y is equal to mx plus c. So here it's mx plus b, doesn't matter, right? So m is nothing but a slope, and b is nothing but your intercept. So what we are doing in the mathematical way, so we used to figure out like what is the value of m by giving this sigma of some formula. I don't want to confuse you guys. If you get bored, doesn't matter. Please pause sometime, then we'll move on to the next one. So these are the value given in general way, in mathematical way. So we can find out x minus x bar and y minus y bar, x minus y the whole square, and blah, blah, whatever the thing, and finding the mean, and etc., etc. And finally, we'll figure out something like what is the m value. At the same time, we'll find out the c value. Then what I will do, I will find out like what is the other values of y and other value of like the value of y. So this is the equation. If I know the value of c and my b, sorry, m and b, and then what are the value for the x, so I can find out that value, right? So this specific, the flow, you can understand how it is coming up. So forget about the actual and prediction, that's fine. But when you are doing your any linear regression, when you are doing in your college or schools, so probably in stats or any mathematical engineering, mathematics, whatever it is, so you come across the specific, the formula and doing all those things. So all these things happening inside your machine learning algorithm when you are implementing linear regression, simple steps. But we are not going to discuss that one. But let me say what exactly the model parameter and hyperparameter. This is simple answer is a configuration. Don't worry about that. Because actually 5-6 years back, when I started my transition from the analytics into the advanced analytics, right? It's advanced analytics, something about machine learning, AI, everything. So when I'm doing that 6-7 years back, so by the time, so really it was confusing with the model parameter, hyperparameter, why we are doing that, right? So it's a simple configuration, putting the values, different values, and then finding the outcome. That's very important, right? So that is nothing but the configuration of the value. I mean that parameters inside your the given equation. You forgot about the equation and all. If you call the like regression, linear regression, or classifier model, or random forest, or KNN, whatever it is, you can go ahead and you can get the output, like you will get some output. But there was a lot of parameters. We used to say as a syntax wise, we used to say parameters. So before, in the normal language, we used to call it built-in function, right? So in the built-in function, we have a number of parameters. We have to pass the value and we'll get the output. For example, string concatenation, something like that, right? For example, I'm saying. So the same way, when you're talking about the ML, right, machine learning process, so there are a lot of functions, inbuilt functions, which is providing by the Python. Nowadays, we're using Python, right? So even R also providing that, but the Python is the robust one now at the moment, right? So during that function, when providing, we have to changes the value of, for example, if I'm asking you guys write a simple function to add the two numbers, what do you guys to do? You'll function defining function a comma b, and you are passing the value a might be a 2, b might be 3, and sometimes a might be a 10 and b might be 15. So you will get the values, right? So that's a simple function. The same way, you are configuring your function. You are defining the function, you are calling the function, and same time you are getting the output from that, and you are enjoying the one. But same time, when we are dealing with the model, when we are playing with a huge amount of data, we have to configure the model with the help of model parameter and hyperparameter. That's very important. Make it very simple. And this is the very, very important, the understanding one. Hope you guys are familiar this formula, right? And this is like kind of when you are doing regularization techniques and all in ML. So we used to we use this specific sigma y1 yi minus mx plus mxi minus c the whole square to the square plus lambda and weight. I don't want to go into detail. Make sure that what is the model parameter? Model parameter, this specific portion, this is nothing but model parameter. And this specific lambda is nothing but a hyperparameter. Make it simple. Okay. So let me give the indication that what is the role of model parameter? What is the role of hyperparameter? And how these things will impact your model. Hyperparameter are supplied as argument to the model algorithm during the initializing them as a key and value, right? It's nothing but A is equal to 5, B is equal to 10, something like that. And the values are picked up by the data scientist or machine learning who is building the model in the iterative mode. That's it, very simple. So now we are reaching almost where we are closing understanding what is hyperparameter and model parameter. So both are same, doesn't matter, right? So just I'm mentioning that hyperparameter, and you can make it that as hyperparameter or model parameter, simple. Okay, let me move on now. Let's try to understand what's the definition. The quick understanding of the model. This is a simple linear regression slides. I'm putting like you're drawing the line. So model parameter or configuration, make clear on that variable that are internal to the model, and the model learns from on its own using a data set. So make sure that when you're dealing with the model parameter, that is going to be a always internal, right? What a data set, what you're using. So based on that, how it is possible, you can ask me. Please wait, I will explain that. And before that, if I want to explain that in simple statement, you may selecting like the font size, colors, underscore, strike through, whatever things in your when you're building the document or we're writing email, something like that. So we used to specify what you like or standard format, font or size. So in that case, you can select and you are sizing that and better way. That is nothing but you are passing the parameter to the system internally. So that based on that, what happening, like you are complete the board document, it's getting clear, and even it's like when you're making a presentation or sending the email. So we're selecting the different font size, colors, and based on these standards, whatever it is, right? So you are doing a configuration for your content. The similar way, the model parameter and hyperparameter working the same way, but the model parameter, this is purely internal. How it is purely internal? I'm coming to that later. I'm coming begin because I'll just go back. So this y is equal to mx plus c. I would say the a c. So here I have my m and b. These are like model parameter. So I'm getting this with the help of all this data. You got it? So I'm getting the slope, I'm getting the intercept with the available data. So internally the system will calculating and it's helping me to put up this y is equal to mx plus formula, and I'm getting the value, right? But what is hyperparameter? We'll see that in soon. Hyperparameters are the parameters that are explicitly defined as the ML engineers by the ML engineers control the learning process of the model. Guys, actually, when we are building something, when we are training anything, like for example, we have to find out, like probably if you guys that have a good background on the ML, at least not good, but at least the medium level or practitioner level or initial level. So probably you will have to do a lot of iteration of finding the model, best model, what is the best model coming up. So what we used to do, we'll change the numbers and we'll try to understand that. But specifically, when you're dealing with the hyperparameter, we never bother about these things. By default, what is available, we'll start using that. But that shouldn't be in real-time scenario. That's very important, right? So one cannot know the best value for the hyperparameter for a given problem statement. So the best value can be determined by either rules of thumb or trial or error. What is that? That is nothing but the hyperparameter space. Hyperparameter space is nothing but what? It's going to be the complete availability, the permutation, commutation, combination of the whole overall thing. Yeah, this is the one, right? So look at here. This is a three-dimensional diagram. I have n underscore estimators and mean underscore relief and mean underscore split, right? So in this case, I can have a number of options. My actual, the mini split from 4 to 14, and my mini leaf going to be like 4 to 12 here. And again, my underscore estimators value might be like 200 to 1000, 200. So I'm keep on putting the different combination of all these parameter, and I'm finding my best one. You don't bother about that. We have a lot of functions and methods that we have. So those things will help you finding out that which one is the best combination. Okay, because when you run this script, So it will give the thousands of lines of output. So no need to going and digging that, hey, what is that? Which one is the best one? So where I need to do that? No issues on that. So only the thing, you need to understand what is the bottom line, or how the basic fundamental is working, right? So the basic mantra is here. So if you understand the basic thing, a plus b whole square is equal to, what is the formula? A square plus b square plus 2ab, right? Simple thing. So if you know that one, whatever the value you give that, if you write in a program, you build that will give the answer. The same way like y is equal to mx plus c, and it's going to be simple linear or multilinear or whatever it is. So if you know the basic stuff, how it is working mathematically, so that's the reason actually for when we are building the model, if you have a strong knowledge of the probability and the statistics, and even more, a lot of other the Laplace transform, reverse Laplace transform, there are so many mathematical things we can incorporate, and we can get the use of that. If you know the basic thing, we have a functions, we call it out, we pass the value, we'll get the output. So think about this one. These are the lot of options we have. So by using different combination of the values, we can provide and we can get that. Right? This is nothing but hyperparameter space. That's very, very important. Right. So now we've gone through that, what exactly the model parameter and hyperparameter. And let me give the high level things like the what differentiating that, how it is. Parameter. Parameter is model parameter, right? I mean it's a model, it should be a model parameter. That's internal to the model. This is external to the model. We'll see that one by one. Essential for making a prediction, right? Because actually when you are putting that one internally, it will calculate and give that one prediction. Like if you want to, like tomorrow going to be rain or not. So this specific model parameter will help you guys. The same way, but this hyperparameter, it's optimizing the model. We have to optimize the model, and ultimately that will support your best prediction for your model. That's very important. And same way, specified and estimated while training the model. As I showed you, right? The tabular column, finding the like what is a slope and intercepts, everything. So this will taken care by internally. That is nothing but specified or estimated. I would say it's estimated while training the model. So internally it will get the data from the data set, and it will create the M and C everything, so that you can get that. So if you are familiar with the regression model, so that is a simple function called intercept. So if you call that method, I think like it's not directly, it's like comes around regression dot, then intercept means that will give the output, and same way for score. The same way, so that will be estimated, and this will be this specific hyperparameter setting before the beginning of the training of the model. So we are planning to give a lot of options. First time going to be a 5, second time is going to be a 10, and third time is going to be a 15, and going to be a 20, something like that. So after some point of time, what will happen? So you can find out the output. Oh, right. So when I'm giving the value of like 5, 10, 15, 20, 25, something like that, by the time you're able to understand, oh, right, I'm getting the different answers. Which one is the best one? You can go ahead based on your option, you based on like the output, and you can very well, you can check with your SMEs. So that's not only deciding by the machine learning engineers. Machine learning engineers over the period can predict, because the person actually more than 12 years, 15 years in this industry, in the specific ML industry. So they can say that, hey, this is the model, you're getting all this output, this one is the best one, so go ahead with this one. Or else you should have the statistician or else SME, subject matter experts in your team. So they used to get like, they used to give, you have to share that list of output, and then they'll find out, okay, this is the one. They'll run through that the list of item, and they'll pick the best one. It will take time. So that's the reason that the entire the roadmap and pipeline for the specific ML implementation will take time, right? So I would say like minimum 8 months to 15 months or 16 months, more than a year, because of building up the data, collecting the data, and building there are a lot of stages in that, right? Basically, I don't know, go inside that, the different phases in machine learning. So when we're dealing that, so ultimately we have to put up that the what is that? We have to set the different value of hyperparameter, and we get the output. And coming to the fourth point, learned or set by the model by itself, right? So we are not passing any value, because actually if you're familiar with the simple linear regression model, we are not going to bother about slope or intercept. No, we are not bothered. Simply we'll pass that data set after giving to that model. Split, make sure that actually testing and training are only for training perspective when you're building the model. But after that, the things will be directly goes to the all the data will go to the training model, so that the model will get the output. That's fine. And this specific hyperparameter, it's setting by the manually in the sense actually they have a configuration. Again, there are different in the real-time scenario, they will do in different way, passing the value to that file, so that the manually the data will be like loaded, keep on changing that manually in the sense actually always going and changing. And during the simple when they're building that, that's fine. But once after everything's get collected, what they will do, the model is all not sustained. I'm telling you, the model is not all stable one. Today the model is doing good, tomorrow the model will give the bad performance because of the data. So when the data is like slightly changes from today to tomorrow, the data will be like it's gone differently because we can't get the proper output, right? So by the time we need to do the different configuration. That's the reason actually we come up with the MLOps team. So the deploying the model and the changing that configuration, it's like not frequently. I'm telling you, it's going to be not in a day. It will not change. Sometime actually there might be like depends on the data. So depends on the data that will be changed. Okay. So as I mentioned earlier, model parameters always like depend on data set. At hyperparameter, it's a purely independent because you are manually setting the value to your parameters and you are assigning that. And same way, and estimated by there are a lot of options we have, the gradient, the descent, and so many things that we have. I don't want to go inside, like it's like a lot of options, algorithms, optimization algorithm we have, we can use that. And here we have estimated performance tuning by the tuning, like we have a grid search and the other things that we have. We'll see them. And decide the performance of the unseen data. And this is specifically quality of the model. Actually, if the quality of the model would be great, then only the performance of the model would be like good. So ultimately, the hyperparameter is a superpower than the model parameter. So that's very important thing. So the best example in linear regression is a coefficient. Supervectors actually supervectors things, and A and N you can specify the weights. And same way for hyperparameter is the learning rate and K value in KN, and so many things we have. We can see that one by one. Okay. So I think somebody's putting the question. What do you mean optimization model?
Sir, we can take it in the end of the session.
All right. Perfect. Yeah. Good. Right. Cool. Say this is the machine learning life cycle. So what we used to do, generally we'll get the data and we'll split the data and we'll try to do the training the model and testing the model. So model finalizing and then putting into that, and outcomes will compare that. So generally we'll split that data, as I mentioned, 80-20 or 70-25. That's fine. That's fine. This is a basic thing actually. When you are learning machine learning and all, this is one, but in real-time scenario it's totally different, because once a model find, like, there is no point of sending the data again to the test, but we can monitor that. Based on that, we can again, it will do in the backend. All right. So steps to perform the hyperparameter tuning. The model selection is very important, because what kind of algorithm you are going to select, that is very important. And review the parameters, right? What are the parameters we are going to select? That's very important. And selecting the searching and right searching method. So like we have like how to search the data and everything, and apply the cross-validation approach. But cross-validation approach is little bit away from this discussion. And assess the score of the model. That's very important, because one step after the specific things, so we have like cross validation approach and all. We have a k-fold validation and all. So that's a little bit away from this today's topic. So I'll try to cover like in the next section if possible. Right? These are the major thing. So Right, fine. So far you discussed about the entire journey, like what is the model parameter, what is the hyperparameter, how it is different, where it's playing the role, and how to identify that. That's fine. So now I'll come to this one a little bit later, because let me discuss this one. The time to discuss the few hyperparameter and their influence on the model. That's very important. So this is one is a very familiar one, guys. Hope you guys are know very well, right? So X and Y actually used to pass the value for the data set, right? And independent dependent variable. And here the classical thing, a random underscore state is equal to 0. So we get the train and test set across the different execution, right? The random state provides the seeds for the random number generated in order to stabilize the model. If you're not specifying this one, what will happen? The things will be like one time we'll get that different output, and again when you're running the same thing you will get the different output. So you want to stabilize your balance, your model. So we have to use this specific what is that, randomizer. So random underscore state is equal to set. So we'll get the same set of set and train set across the different execution. But if you ask me like it needs to be something like that, yeah, you can change that if you want. But when you started practicing this one, so better you go ahead with a 0. Sometimes people use 100, 1. It's like case by case different. So the random number, if you omit this one, system will generate this number and leads to unpredictable behavior of the model. As I mentioned earlier, like if it is not mentioned anything, one time we'll give this something, some value, second time we'll give something, like you keep on trying that so that you'll be frustrated on that. Okay, good. And next sample is a logistics regression classifier. This is one of the very important thing. Actually, this is inverse of regularization strength. So regularization techniques we have, that's a different one. So regularization techniques is nothing but to suppress the noise and to control your entire data set and on the ground. So in that perspective, so the logistic regression, they're giving the C value, the logistic regression classifier, and it's related to the lambda. Probably you can remember the specific lambda value in my earlier slide. If you want, I can, this one. Okay, so this lambda is derived from the specific C value. So if you ask me like where I go and see, means all the functions is built in, right? So it's everything's be available inside that. So that actually we couldn't find like how it is internet doing, but you should understand that it's very important. C is equal to 1 by lambda, right? So that specific regularization parameter, it's very important, so that it is actually indirectly professional, inversely proportional to the C, so that the based on the value of the C that we keep on changing. If you ask me, if you're asking me, say that if I give the C value, what will happen? Try this, right? So we have to try this. Basically, we used to go with the best standards, 1000, because these are the very minimal thing. But when you come across the ML journey, that's very, very important. That's very, very important to understand, like building the model. Some cases we cannot give it just like the numbers. Make sure that, but we have to make sure that what are the hyperparameters we have to use in when you are building any model using algorithm. That's very important, right? Cool. And again, that is one of the best thing, like a decision tree classifier. So here we have what is the citations, and so what is the entropy and maximum depth of the decision tree, and again the random state. So these are something like mathematical related things. Basically, this specific thing determines the maximum depth of the tree. That's very important. That is very, very important, right? So the same way for entropy, and we have the other options as well. I don't want to confuse you guys. There are a lot of options we have, so we can use that, right? Guinea, I think that is another option, so Guinea, I guess. So we can use that. But if you ask, if you can pass that value, different value, instead of entropy, you can pass the Guinea values, you can get the output, and you can change the maximum depth value 3 into 5, 5 into 10, something like that. But the maximum depth, based on the data set size, right? But in real-time scenario, it's going to be very huge. So you can classify something like that, like, right? The decision tree structure classifier, it's kind of like, what is that? It comes again the random forest way. So it's a complete tree structure, so that you have to decide and which one we should use and which one should not use that. So the maximum depth You have to analyze and you have to put the value, right? It's not a standard one. We have to use 3, 4, 5, something like that. So it depends on the data, volume of the data, and the possibilities of your independent variable combination over there. So you can use that max content. That's very important. And least or regression. This one actually I mentioned that alpha value. Either you can give the alpha value is equal to, like, we have regression parameters as a 0.1 by default they used to give. And again, this specific the user regression also, like when we are regularizing your regression. So try to understand that when we are building the model, not only collecting the data and doing the EDA and finding that select for future selections and applying that algorithm and finding the score. No. On top of that, we have to do the hyperparameters tuning, and then we have to do the regularization techniques, and then we have to find out the outcome. It could be right root mean square or any other things we can find out. So after that only we can stick on to that. And remember that there won't be a, like, one model, one data set will always not, I will support one algorithm. No, it can be support more than one. So in the case if it's going a more than one, so you can bring the Ansible model and you can perform on that. And we have a voting methodology. There are so many things on that. Bagging system, there under this Ansible technique, there are so many techniques on that. So that probably you might know that one. And same way, here the principal component techniques are very important. If the futures, the future, I mean like number of columns, the independent variable is a very huge number, then we used to go ahead with the PCA model, because we cannot have like 100 features with like prediction is very really challenging. So that when you're applying the principal model, then that will be give like a number of principal components. So it will make sure that like it will give the four different components or 5 different components. And again, when you're applying that as principal component analysis, so there may be like a combination of different values. When you're passing the 10, then your 50 column, right? So that will give the 5 column precisely. And then you can take that value and you can play around with that. After that, you can apply the all models and you can get the output. And same time, if it is going to be a 2 means, the system will internally find out like which one is the best and give the 2 columns. But very careful on that. When you are doing the principal components, it's not so easy and it's a very useful, time consuming, I understood, but we have to be very careful on that. So why I'm telling, so when you're going for each, not only for the principal components, when you're building any model, that's very important. That's very, very important, right? So it helps to reduce the number of independent variable. Probably you know that's in detail about like the PCA model, right? And the next one, it's going to be hyperparameter. What is that? Sorry, this is a KNN method. In KNN method, again, this is going to be neighbor is going to be 5 and P is equal to one value is power parameter value is like a value, and metric is going to be like mini cos P. So this is actually, these are the simple things like Euclidean distance and Manhattan distance and all. Actually, internally will calculate that. If you guys are familiar with all this is a mathematical thing, you can understand the reason behind the specific items. That's very important. If you're providing P is equal to 1 means, then the system will take care like it's equivalent to that Manhattan distance way it will work. And if it is going to do, and based on that, it will work on that. So that's very, very important thing here. Right. So far we have discussed about the different hyperparameter in quick way. So still we have around 20 minutes. I'll try to cover and we'll go for some simple demo because it's just in that 60 minutes time. So I need to cover entire portions. I think I skipped one thing. Yeah. So here the steps, as I mentioned, select the right model. That's very important. As I mentioned, like it's not going to be selecting a one algorithm. No, we can select a multiple thing, but one by one, right? And review all the parameter list in the model. So when you're using any algorithm, so make sure that in scikit-learn active library, if you go and check that, there for specific what is that? So a specific algorithm, you might have an n number of parameters. So we need to find out that which parameter we need to use that. That's very, very important. And finding the method, right method to set the hyperparameter and space. That's very important thing. And same way, the applying cross-validation method and K folder structure, so that like it will improve that the performance as well, right? That's very important thing. So initially, this is going to be like this. So once you introducing your hyperparameter tuning, the model will get like, we want to understand like hyperparameter tuning and tuning the your value, and you'll get the output. Again, you can train and test the data. That's a very important thing. Okay, cool. Right. Cool. Yeah. So hyperparameter influence the models. So if you take like linear model, what degree of polynomial features we should use, so that will give that information. So decision tree, what is the maximum depth you can allow? That's what I explained that. And what is the minimum number of samples required at the leaf node and decision tree. So that's a random forest will help that. And how many trees we should include, so that then for that will support like neural networks, and how many layers we can use that. And same time, see how many layers for like a gradient descent and all the stuff. So these are the major influence for the hyperparameter for multiple different sample perspective given. Actually, there are a standard what is that tabular sheet is there. So that is actually the reference number for each and every parameter for each algorithm. So probably like if you get a time, so you can just search and you can get that. Just I couldn't like get the time to include in this slide. So, but that specific things are giving a guidelines. What is the default value? Why we shouldn't go beyond that? So that aspects actually we have so many things in it. So we have to be careful about that. And same time, they have some guidelines. So it shouldn't be more than that. For example, by default depth is equal to 5, or k-fold structure. Actually, mostly like we'll go with the 5 means as a standard one. So they will give the detailed information saying that why you want to go to 5, why it's not below that. Below that it's fine, but they will give the like the pros and corners. That's so that you can understand why it is important. Okay, so that is a very, very important thing. All right. And we have so many options like hyperparameter optimization techniques, like the manual search we have, and we have a random search, grid search, and so many things we have. Let's quickly show some demo. It's already executed one. Okay, I'm not going to execute because actually I didn't check that like all the files are available. Okay, so it's already executed one. So hope you know this one. I'm using like the Pygmalion's diabetes data set, and I'm doing all this initial EDA process, right? And here I'm giving my train and set weightage for this one. So when I'm passing the different entropy and Gini and splitter, right, and best maximum depth 50, and say look at this one, the 50. Basically, I'm giving the different combination of 50, 70, 60, 80. These combination of the different hyperparameter I'm creating, and I'm passing this to the 5 different model as a parameter, and I'm going to train this one, and I'm going to test this one, and I'm going to print the accuracy. This is manually I'm doing. I'm not using anything. Straight away I'm using that. So the accuracy of the model 1, 2, 3, 4, 5, I'm getting this one. So look at this accuracy and the difference with the different parameters, so that we have passed over the list, right? But this is tedious job while you're running the n number of, see, if for example you're saying, hey, I have only 4 combination, you can do that. If it is a 400 combination, so in real-time scenario, nobody will go and do this one. That's correct. So that's very important thing. Okay. So we have to be careful about that. This is actually manual one. Let's see what's happening. So grid search. So in the grid search, what I'm doing, I'm bringing my grid search here, right? And I'm passing all this value, and I'm highlighting all this the algorithm inside that. So I'm passing this parameter to my grid search, and KNF, this is my model, right? Already I created classifier model here, and passing this grid parameter. This is what's decided here. So here I have 8 combination. Okay, I'm going with this. So 4 different algorithm I'm using. So after running this one, I used to get 8 subsets. 1, 2, 3, 4. Okay. So 4 algorithm, 8 subsets. So each and every giving a different combination. When I look at this one, I could understand, hey, what is this? Simply, it's like giving a 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5, and we have an algorithm I'm specified, whatever I'm specified. You can understand that, right? Which one is the best? No worries. We have a simple function saying that how the we use like regression.score. The same way, best underscore params underscore. So that will give the algorithm auto and n underscore neighbor 6 is the best one. This is giving output. Okay, which one is that? Yeah, this is the one. Okay, so this is the one. Actually, the grid search is giving the example. I will like giving that the best one. So after I'm passing this one, so this is all done by my simple grid search option. So grid search is simply, you can assume the hyperparameter space what I given to you guys, right? So in the grid search, in the space, the given hyperparameter space, the things will go and finding the availability of the combination of different data and what are the algorithm you are passed. So based on that, it is giving, and this is also providing me, this is the best one. Okay, fine. This is the best one. How we are saying, like, I'm not relying on even the machine. I couldn't like manually putting that all the inputs like in one by one, and finally I can find out the answer. So that will take time. So that I'm coming to the machine computer system. So I'm doing my mathematics and everything, but still I'm convinced with my result. This is telling the best one is this combination. Which combination? Auto n neighbor is equal to 6, 1. Then let's see that. So the result of the mean square one. That's fine. Which one is the best score from the above list? It is then simple. Already we found the best parameter as this one. So compare the 32 combination of this one and you will get the answer 7.73944,749 is the highest value. So which one is that from the top? 1, 2, 3, 4, 5, 6. This is the one we are looking. The system says, hey, this is the best one for me. Then I'm finding which one is that? Again, 6 from the top. Numbering 1, 2, 3, 4, 5, 6. Look at carefully all this combination. The other data really is less than this one. Then I'm finding this like a score. Which one is actually is giving you 70, that's fine. But which one combination is the best combination? My algorithms given that value like auto neighbor 6 is the best one. When you look at that account, it's saying like 0.73 is the best one. So this combination gives me a best result with a simple one. Otherwise, I'll be really confused. So that when I deploy this model, I can directly go and apply this one and I'll get my score and model. Further things. We have a lot of other things we have, right? I can go ahead on that. Okay. So this is how we used to do that. So the same way, actually, I've done for something for random forest. So since we have 9 more minutes, so let's catch up the questions instead of hanging over here. Let me see the things. Right, anonymous second. Okay, who is given that? How does one decide a number of components in PCA? It's experimental again, of course. That's what I'm telling. When we are building the machine learning, that's AI ML world, not just like a building, not just like, because actually we have worked on that. Even I build like a lot of applications, right? It could be a web application, mobile application, whatever it is. That's earlier experience, and I moved into the analytical and jumping over here. That's fine. But comparing with the normal application and the ML1, we cannot like do just like that, because actually we are dealing with the data. That's very important. So when you're dealing with the data, we have to be careful, and we have to do with multiple way of iterations. That's very important. That's the reason actually when you talk about AML, we have to be very clear, like the data needs to be cleaned properly, right? There are a lot of steps before that. That's the reason I said, if you ask me like what is the roadmap for the machine learning means, it will take for me at least 16 to 18 months based on the data, volume of the data. Volume of the data is like, as long as you are giving the n number of data to me, I'm happy, but the data should be a reasonable data. Otherwise, I'll be collapsed, right? I cannot find out the one. But slice dicing that, and we'll finding that problem statement. I need to get that only the data, and I need the what is exactly the problem statement, fine tune that, and get the data from the sources, and you do all the exercises, and then applying all the stuff. So the PCA is the best option. But when you're using a PCA, we have to experimental point of view, you have to do that. So, okay. So probably like you can find my article. Again, I wrote in a year back in Analytical Vidalya. So how to handle that situation. There are combination of things like there was a nice article. I very much interested, like I wrote that one. So probably you can check that one. So that is my answer for you. So slides will be provided. Let me think about and share with you. Okay, I'll try to do that. It's not a like kind of like what is that, a very secret one. I'll try to share this one. And is the percentage of partition of the data falls into hyperparameter for testing? It doesn't matter. That's what I said, right? So when we are doing with this, probably you know, right? Before you split the one 70 60 or sorry 70 and 30 75 25, after that you are fitting the data, and then you are applying your hyperparameter. It doesn't matter, because actually when you look at this one, let me close this one and go back here. Yeah, see here. So here actually we're splitting all your classifying model. Yeah. So you splitted your all the data, right? 34.3. It's a 70 and 40 for 70 and 30 combination. So it doesn't matter actually when we're dealing with like the for trial and purpose, or like when you're learning machine learning, that's fine. But in real time scenario, the most of the thing will go to actually to like once the model that in production. That's very important. Okay, right. Right. What is the meaning of optimization? Optimizing the model. Optimizing model, that's what actually, so you'll try to get some value, right? So if you want to improve the your score, so each and every assessment or whatever the exam, whatever you say, so you are studying well and you are writing exam and you are not getting the score. What is the problem? You need to find out that. So we need to find out that the painful areas and lagging areas. So where we need to jump in and we need to figure out that, hey, these are the like the gap, and these are the very important thing we need to look at that one. So that way we are finding the gaps and improvisation. For example, like so training that one, like myself, for example, I want to read some specific content. So I need to read myself, understanding better way. So I'm optimizing myself to perform my exam. Same way, when you're doing a machine learning, there are a lot of things for optimization in different stages of machine learning. That's very important. Not only for this completely AML stage. So we have to take care of right from the selecting the source data. There also you need to concentrate on optimization. So you cannot just like that all the data into the model. No, that's it. Never end process. After 5 years only you will get the model, right? So that's very important. Optimization is like you're improvising your performance. Sometimes this is a debatable thing. Basically, it's a debatable thing. Actually, when today I'm giving something, it's performing well. For example, I'm running the restaurant. So some set of things actually dine in and take away. So some sort of things I can do it in dining only. Something like we cannot do it in takeaway. In earlier days, you cannot get the coffee as a takeaway. That's very challenging one, because we can get all your items like Indian items or anything like bread, whatever things you can get that as a takeaway. That's fine. But now you can get anything as a takeaway, almost 99%, I believe, right? And specifically they customize some pattern to the only for takeaway combo kind of stuff. So how they're doing, they're finding that the opportunity, business opportunities for that, how they're finding that based on optimization techniques. So wherever possible things available, so they're improving that business and they are filling all the gaps and makes the strengthen one streamlined process. That is nothing but optimization. That's very important. Okay, and then how does one decide the number of, I think we are answering this one. And again, how many play generic algorithm hyperparameter tuning? This is simple here. Actually, I've shown the slides, my slides, right, Shiva? So it's a very simple thing. So all the algorithms, it has a hyperparameter simple saying, it's not actually in terminology wise, we are saying hyperparameter. If you have the background of programming language, I would say it's a simple syntax, and parameter, it's not an optional parameter. Sometimes it could be optional parameter, or sometimes it's a mandatory parameter. So what you used to do, like for example, concatenation, string concatenations, and the string length, or else like what is else, like in sometime actually finding the extracting the month from the date, something like that, or extracting the year from the date. So we have a lot of methods in it, right? I mean a lot of options. I mean like parameters, right? Parameter is like functions. So similar to that, that's all. But we try to understand, because we are playing with the data. So we are applying that the reasonable value for a hyperparameter, you will get exactly what output should come based on the volume of the data. That's very important. So that hyperparameter tuning is like, so it's already existing in that the subsetter in the simple function, right? And the passing value is in your hands, and you have to consult with the SME and pass the values. That's a very important thing. Okay, good. And even nowadays, actually, there are hyperparameter in finding the like value exactly based on the data. We have a lot of tools that we have available. So that tool will extract and give that the detail about, hey, these are the hyperparameter value we are missing. You have to pass this. But we cannot rely on that. If you are strong enough with the base, then you can justify the answer. But you can simplify. You can save your time. That's very important thing we have. But hyperparameter is already there. You have to pass the value. That's it. As I mentioned, date function, string function, numerical functions, the basic function what we have in our programming language. Same way here, but here it's very, very sensitive. That's very, very sensitive. That's what. What is the best range of parameter to begin with? That depends. Okay, it's a hard question. So what is the best range for the parameters to begin? Like it depends. Okay, that is the one guidelines is there, because actually now we are growing with all these ML and AI across. So that really will give the clear picture about that. Okay, right. By using we have got these best optimization techniques. That's what I'm telling actually. So we cannot decide this optimization is good or bad. So we based on that the data, nature of the data, and the data has been selected for the ML perspective. ML tabular. Hope you guys are know like a tab. What is that? What is that? 1 minute. Let me pick that word. Structured data, unstructured data, and semi-structured data. If you're talking about all these kind of algorithm, if it is going to be like the structured data. So when you're doing the structured data, what are the data? But passing that data with the combination of different algorithm, we'll get the output. Then we can decide, hey, this is the one thing we can go ahead at. So that way we can do. I think optimization model I've answered. Oh, there are big questions. I've been traveling since Monday. Unfortunately, I lost the session. Okay, that's fine. Okay, so we can get the model parameter, hyperparameter of the decision tree. So this is, see, that's what I said. Like when we're building the decision tree, there is the options we have. That's clearly you can understand that there are few parameters, that depth and all the, it's going to be Guinea model or other model, something like that. Model parameter, if you have equations internally, you can see that. Okay, that's the one. So pretty much I covered. Okay, somebody's searching job. I need to be a perfect and random for addition. Everything. Mohan, actually it's everything. So that's what I'm telling you. I'll try to deep dive and digest the concepts. So, and there are a lot of online videos and YouTubes, everything we have. So just explore that, and definitely you can get that. And same time, try to understand the industrial standards. So that will help you a lot. Okay, so deep dive. There is a lot of in term things are there giving. So play around with that. So dedicate yourself for at least 6 months, or I would say minimum 6 months dedication on this for freshers. And even people are experienced people, they need us at least 6 months to digest that. If there is no programming background, that's really a challenge. But they have to digest that one and come back to this one. So it will be really easy. Otherwise, how fake they're struggling, something like they couldn't finish that one. Could you please tell me how to decide the range of the hyperparameter at the beginning? That's what I said, right? So here we have given that some data. I use like for 8 combination. Probably you can put a 9 combination, and even now we have like some other way around, like some automated way to build the hyperparameter set. So you can have it a list of, for example, for parameter, let's say, sorry, I'm taking too much of time, but it's very useful, I believe.
Yeah,
Okay.
yeah, it's fine.
Yeah. Okay. So when you guys are playing around, which one that? Yeah. See, let us this take one. So what I will do, I will keep my Excel or see some simple XML file or simple CSV file, the combination of all three in different scenarios, different like position, and same time range might be differently. So let's say like the hundreds of combination I'm putting in my Excel sheet. What I will do, I will automatically is a kind of automation. So keep that as a feed for this parameter grid and pass to this specific what is that? Yeah, specific the grid CV. Then my complete automation will be good. I don't want to put all the things as a texting. See here, I'm putting 4 item and again writing this one. The simple way, what I will do, I'll have an Excel sheet. I'll keep on adding my permutation combination of all the stuff, right? As a crazy guy. So I put that, I'll get the output. That's it, simple. Okay, that way you can implement that. It's not a big deal. Okay. So what is the meaning of the reducing the noise of the model? Yeah, that's a good question. Basically, the noise, there might be like, the multilinear regression model. We used to say like y is equal to beta naught plus beta 1 x1 plus beta 2 x2 and so on. That beta is nothing but beta 1, beta 2 is nothing but a noise. You can ask me, what, say, you was telling the equation. Yes, understood. But when you are doing a regularization techniques, that's what I said initially. There have a regularization techniques to reduce the noise of the data, cleaning the data and finding the data, wrangling the data. It's like different. It's a different. But when you're doing this kind of regularization, that's what I said. Like we have a lot of stages. We have a data collection, data EDA process, data wrangling, everything, etc., and future extraction, future selection, blah 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 blah, what are things. And to come into the model, I'm putting a lot of model relevant to the problem statement and bringing that. After that, I'm doing hyperparameter tuning. After that, I'm doing a regularization techniques. So why this is completely filtering the noises from my data. Sometime actually, not only that the empty column or duplicate values will not answer all our questions. There might be a data too. That's a lasso method, right? Lasso technique. So that will what is that? It will squeeze the data as much as possible to reduce the noise. I think you got my answer, right? Please can you provide me the presentation on Jupyter Notebook? Yeah, I will try to give this. Okay, it's not a big secret. I will share with you guys. How hyperparameter regularization is related. That's what I said. Actually, if you look at that, the equation, what I showed you, right? The sigma of y, yi minus xc plus lambda of w. There actually regularization is there. That lambda represents nothing but regularization. Regularization lambda is nothing but c is equal to 1 by lambda. If you understood that logic, okay. So I don't know, like we have been crossing 6 minutes, no issues. So let me quickly bring, because otherwise it will be yeah, which one that? Yeah. So this is your hyperparameter, and this specific thing actually I can call it as a regularization techniques. I can use this. What is that? What is your question? Which one questions? Reduce the model needs. Yeah, regularization related. So that is a regularization related. That's lambda, right? When you talk about like regularization techniques, this specific equation come over there, then the lambda will be playing a major role, and the weightage will be going a very important thing. So that is a combination of that one. Okay. What is the meaning of reducing? Okay, right, that's fine. And but that if the data is wrangled, what noise you are talking about? Data is wrangled is just clearing the data. cleaning the data on top of that noise. See, if I'm speaking, right, I'm speaking the right words and right sense, but there might be like some internet issues or signal problem, my side or your side, there might be signal issues, there is some noise in communication way, in electronics and communication way. I'm communicating that one. If you're familiar with that one, so probably you can see on. Probably if you're speaking with someone, everything is fine. Your mobile is good, their mobile is good, but when you're speaking, you're not able to hear some background noise will come out, right? So that's not that is nothing but after doing all the data wrangling and all, still there is a scaling up, scaling down. We have a like scale up, scale down, maximizing your data, something like that. So we need to handle that one. So that is a kind of a noise. Again, regulation techniques that will reduce the noise better way. Okay, so I think I covered pretty much all the questions. So you guys can reach out me through my LinkedIn way, and even I have I'm regularly writing all my articles across and Data Analytics Vidyalia and Data Science Central, and even I have my own blog, Shanta's AI View, and I have my YouTube channels. So probably you can reach out. That YouTube channel is a little portion only have. I need to build that, but you can join, you can connect me through any social media. Okay, all your questions and collaboration works will always accepted. Noise is outlier. Outlier is different. Outlier is totally different. Outlier is totally different. So you can see that outlier is naked eyes. Noises is like you cannot see in your normal eyes. Simple way. Outliers, when you put that what is that box plot, you can find out that you put that some holograms view of EDA process, so that you can find out, hey, this is not fitting into my belt, so remove the data. That is outlier is different. Noise is something hiding from your eyes. That is very important. Okay, so from that you can find out that is different. Noise is different from really from outliers. Outlier, we'll do all the things in our still. That's what I said. Today the model is working fine, and after 3-4 days the model will go down because the data if it's working fine, then that is nothing but data drift. We have a data drift, we have a model drift, so many things we have. So it's a long process. I think already more than 10 minutes. So I hope I covered all the questions and answered your questions, I believe.
Yes, sir.
Yeah.
So thanks a lot, Shanta Babu. On behalf of Analytics Vidya, I would like to thank you for your time and for delivering such a wonderful session. And I'm sure our audience find it insightful and hopeful. We can conduct more sessions with you in the future. Thank you.
Definitely. Okay, guys, I think hope you understand that tuning. So let's go back and perform and implement your model. Let's catch up in next session when we get the time and we align with you guys. Yes, thank you. Thanks everyone. And thanks Analytics Vidya and Tapa. Thanks for the opportunity. Yep. Yes, thank you. Yeah. Bye. Yes.